I'm going to start off with a few select things that I find really interesting with JDK 23. I know I had in my synopsis that I was going to handle scope values and other things like that in virtual threads, but given that this is going to be an hour, that's going to be tight. So I may drop that one, and in all likelihood I will. But let's take a look at some of the things that I find interesting with JDK 23 and 24. So why is it 23? You may be thinking, well, 24 is out now. What happened? When I submitted the talk, it was Java 23. I didn't even think about the future. so that's why that is. But stream gatherers is a new advancement. I think it's an advancement for 24. So back then with 23, you know what? I don't know, but it's either coming out soon or it's out now. But stream gatherers have a really big impact on me. So how many of you seen stream gatherers so far, or attended a talk with anyone doing a stream gather? I don't know if anyone had a talk on a stream gather. Let's go and dive right in. I didn't see that many hands, so I think this would be extremely valuable. So stream gatherers are a way that we can do collections or grouping as an intermediate operator. So let me ask you, if you want to do a group by and then continue to do something else in Java, if you think about it and you think about all the operators, you can't, right? You kind of have to do whatever you need, your maps, your flat maps or whatever. And at the end of it, you're going to have to do a collectors, right? Collectors.grouping by. But what happens after that? Well, you end up with like a map structure. So then you have to do entry set, and then you got to do stream again and do some other processing. So what this one is a way that we could do intermediate operations, and we could do things like group by, and not have to materialize a collection and then continue on. We could just keep everything as intermediate operations and lazily only get the list whenever we are ready. Okay? And that's the idea for that. So there had been many requests for the Java team. Hey, we need this intermediate operator. We need this intermediate operator, that they decided to say, hey, you know what? No. Why don't we do this? Why don't we make it flexible for you to use? So we have stream gather. We have that method as part of it. And it behaves very much like collect does. And that's the idea for that. And given this, you can transform events one-to-one, one-to-many, many-to-one, or in a many-to-many fashion. So if an element comes in, you could decide, hey, from that one element, poof, I want to, expand that to many elements, or take many elements and aggregate them and send one element from there, or take many elements and create many other elements. So whatever you want to do, your choice or the choice is yours, and you get to do that. Okay. You can track previously seen elements. You could do short circuiting and turn something like infinite streams to finite ones. So let me explain to you the methods on this one. The methods we have are initializer, integrator, combiner, and finisher. I like saying it that way, finisher. All right. So these are the four methods that are available for us whenever we create a gatherer. Initializer sets up the state. So what do we mean here by state? Well, I have a stage here. This is great. So let's say something is coming in. That's the input that's coming in. And what I get to do is, let's say I have a little bag here. I'll use these napkins here. So things are coming in, and what I want to do is I want to put that into a state for whatever reason. Let's say I just want to aggregate things by 10, for example. Element comes in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And now I fill this bag and I get to do that, right? And so that's an idea of what that does. But I need to initialize this state, and that's where the initializer will be coming in, okay? The integrator integrates a new element from the input stream, which is bring that in. Possibly inspecting the private state, ooh, and then emitting the elements to the output stream. That's what the integrator does. The combiner is used when you're dealing with parallel, because you are running in a fork join pool, and so therefore you have multiple collections that are needing to be merged. So if you are running in parallel, that's where you'll use the combiner. The finisher. The finisher is for tidying things up. Maybe you still have some elements in your state that you want to do something with it. Maybe you want to forget it. Maybe you want to pass it on. So when things are done, you can call the finisher to decide what to do with it. Okay? So the steps. We're going to be creating a downstream object. Once we have that downstream object, that's going to represent this side of the stage, right? Here's my input. That's my output. That's going to represent the downstream. So I'll have an object called downstream that I'll be using. We have the private state, which was the bag of napkins there. And we'll call that by calling get. That's going to be pretty interesting here. Obtain the gatherer's integrator by calling its integrator method. If there are more elements, invoke the integrator's integrate method, passing it to the state object, the next element, and the downstream object. And again, if you have anything else, you will invoke the finisher. So gatherers are also meant to be composed. So if I have a source, I could say gather, 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 gather. Or I could say gather and then chain my gatherers together. So I could say something like A and then this and then this and then this and then finally there do a collect and collect things inward. Friend of mine, Todd Ginsburg, he's been loving it. And so bookmark this one. I should have gotten a QR code for you, but if you're taking notes, write it down. Look for gatherers for J. What he's been creating are a list of different gatherers that are highly useful. So I want to make sure I promote this. It's all open source as well. I don't know what license he put on it. Oh, it's an Apache 2 license, so you're good to go. So sure, if you're going to have some fun, do it and try to create some gatherers of your own. But for a lot of these, they've already been created, and you can use this particular library. All right, let's take a look at how this works. All right, so here I am, and what I want to do is the following here. And let's go to this simple gatherer over here. And what I want to do is the following. And I kind of want to just do, I'm just going to duplicate this test in here. Test at GIDS 2025. Yeah, here we go. All right. So what I want to do here, let me just find a way to expand this. Okay, so that way we get to see this. And I'm going to kind of do what this one is over here, but I'm going to say gatherer, and I'm going to leave it right here. Okay? Gatherer T, A, R, which are the generic types here. T is the element that's coming in. A is the aggregate, and then R is the value that we are returning. So for something like this, I could say gatherer, and an integer is coming in. That's this side, right? That's the integer that's coming in. Next is my state, wherever you are. Yeah, this part right here, right? So elements are coming in. What is my state? So I'm going to make this one a list of napkins. No, I'm not going to do that. I'm going to make that one a list of integer. Beautiful. And then R, which is this one right over here, R is the result. So the things that are coming in, I decide what I'm going to throw out, right? And that's what R is. So let's say in this case here, I want to do list of integer, right? I'm going to take that napkin and throw it out. Okay, so I will call that my gatherer. Again, it's kind of like the one in the bottom, but I am just, doing all the parts here. Okay, so pretty cool. Now, the initializer, thanks AI, AI takes some of the fun out of it, but it filled it up anyway, so there it is. The initializer takes a supplier, which is, what is that state? Well, what is the initializer doing? The initializer is, creating this collection here, so that way I can use it. That's what that does. So that's the supplier, and that's what I want to use. So voila. Next, what I want to do is I want to bring in another method in here. Let's take a look at override methods. And this one's the integrator. And there it is. So the integrator now has the following. Let's take a look at the types that should be here. They kind of flipped it around, but you just have to remember what it is you're dealing with here. A, remember, is accumulator. Think of A as like that. T is the element, and R is the result. So let your editor guide you. All right, excellent. So here's the integrator, and let's say I want to do the following. New integrator, and it will fill in the rest, okay? Now, let me just state right here, you're like, man, that's a lot of work. But remember, you're likely going to design an integrator and then use it multiple times, so this kind of design thing is not something that you're going to be doing 10 times a day, every day. You're just going to, design something for yourself. And if you're going to be using something like gatherers for J, then you're just going to be using gatherers for J, and you don't have to worry about all these funny types here. So what is it that I want to do here? Well, I have this Boolean here. Let's talk about that. This Boolean is, do I want to continue or do I not want to continue? That's going to be the short circuit, okay? Like I get all these elements and, at some point you want to say, let's say it's food, right? Someone brings you a plate of food. At some point you're like, oh, that was good. All right, return false. I don't want any more food, right? So that's the idea there. Do you want to shut off the faucet, essentially here, okay? So I'll just keep things running here, and that's perfectly fine. Now, what do I want to do with this? Well, maybe I just want to add a element to this. Maybe I don't. Maybe I could just decide what to do, right? And that's what the state is. And what I can do is, let's take a look right over here, given this element right over here. So I have the state. Oh, this is very interesting as well. Your state is not a member variable. It keeps coming into this function. So you may find that a little bit of a surprise. So there's the state, there's the integer, and then there's the downstream right over here. That downstream represents what you're throwing over there on that side of this stage. So I can add an element to there, and I could say downstream, push that, whatever that state is. The state is this list of integer, and I could send that further down, okay? Each and every time. Well, that one doesn't make too much sense, so maybe what I'd like to do is state add, then I could do if size is equal to 10, which is the one I was trying to do. I'll bring that one over. So what I'd like to do in like this small little example here, all I'm doing here is I'm taking an element and adding it, and then I'm just going to ask the question here, is this size of 10? If it is, then there it goes. I'm going to throw this bag of napkins or throw this bag of items over to the output. The output is going to be represented by this downstream right over here. Okay, cool. And then I'm just saying, I'm saying true. Okay, but I'm going to add one other thing in here for the downstream. I'm going to say maybe state and clear, right? Because I want to start over again, or make a copy of it. I think what I did there is I made a copy of it, or something like that, because that's the new state. Okay, sound good? Pretty easy. The last one on here that I'm going to be adding is, oh, by the way, this right here is in gray, so I could replace that with a lambda. There we go. And there's that one. And I think I'm going to put this one right over here. And let's go ahead and do another override method, and that is the finisher. And so here it is. So this one is a finisher in here. The finisher requires that this is a by consumer, and here it is. So this one is, well, we're at the end of this. And so I've been grouping things by 10. And so there's no more elements coming in. And let me get my bag over here. Just something I found underneath the podium. But elements are coming in, but I have 6 in here. I'm like, what? and like there's no more input. Like, what do I do with this? Like this just has 6, right? And so that's where the finisher comes in, or whatever state, or whatever you want to do, that's where this comes in, okay? So this will bring in the state and the downstream. What do I want to do with that? Well, I could just say downstream, go ahead and push the rest of that. Nope. The rest of that state onward, okay? Now, I'm not doing a parallel here because I have no intention of parallelizing this, but those are going to be the 3 main ones that you're going to be using, right? The initializer, the integrator, and the finisher. And then you can create your own with that. Pretty cool, right? That was under 15 minutes. Did that work? All right, excellent. So let's take a look at what that will do. So here it is, probably a little bit cleaner on here. But yeah, there it is. There's my integrator here, and we know what that does now. So I'll add an element. I'll ask about the size. Oh, here it is. I'm making a copy of it for that downstream list. So I'm not affecting my state, pushing it downstream, and then clearing it. Returning true because I want to say, yeah, keep this coming. That's what that is, okay? Now, I'm taking a stream of 10 and using gather, and here's how we use it. There it is, gather, and go ahead and plug in that my gatherer there and run that as a list. So let me go ahead and run this particular test, and hopefully everything runs. And there it goes, okay? So it works great for 10 elements, okay? Now, on this one, let's do this. Oh, interesting. So this time what I want to do, let's throw some things at this. So I'm going to create elements of 50. I'm going to do a gather on each one, and then I'm going to collect things as a list, okay? 1 through 50. Well, here's my expectation here. Am I going to meet that expectation? My expectation here is that I should get bundles of 10 up to 50. Boop, 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 boop. There it is. And that's what I should be expecting here. So let me go in and run that. And yeah, that works out well. Cool. Nice. Here's this one. But this time I'm going to use data elements that are not divisible by 10. Take a look over here. I am using 1 to 53, right? That's not going to fit. What's going to happen here? Well, this is what's going to happen, right? No remainders. And why isn't it going to happen like that? Well, take a look here. I have an initializer, I have an integrator, but I have 53 elements, which is not divisible by, or, a divisor by 10. So if that's the case, I'm just going to still get 50, even though I have 53 elements, okay? And if I run this particular test, let's take a look right over here. There it goes, okay? So next, what do I do with those remainders? Well, here it is. Here's that finisher. Here, let me convert that to a lambda here. And there it is. So if I have any remainders, that's what this is over here. I'm just going to push those downstream. And therefore, what's the answer for this? That's what the answer is. That's what the finisher does for us. Okay, you got it? Okay, cool. There are different flavors that you can use as well. So here's this one over here. Sorry if it just looks like a lot of code here. But let me go ahead and replace that one with a lambda. But one of the things that we are doing here, well, for one is I'm creating the integrator outside. And so therefore what I'm able to do is just plug that one in, okay? So that's pretty cool, some of the things that I could do. And let's see, what else was I wanting to show you with this example? I think that was it, because what I'm doing here is, no, I think we're good here. So you can create gatherers that way and do that. Here's this one over here. Let's take a look at this one. This one's a gatherer of void. Ooh, wow. What's this one? This one's odd. What am I using on this one? Actually, so this is one here called the integrator with void and integer and integer. What does this one mean? This one means I have no state, right? This bag of napkins. I'll put this away. I'll just call it the bag of napkins from here on out. This one means I have no bag of napkins. I have no state that I have to deal with here. I'm just taking elements and pushing it onward. Okay, I'm not aggregating them or anything like that. So you can create stateless ones. Great. Here's another one. So the reason why I want to bring this one up is, what if you want to create a gatherer and make it parameterized, right? And what if I want to say bundled by 10? Well, for this strategy, what you do is you just create a method for that, right? And here's that bundled by. Here's my I over here. And take a look at what I'm using here. I'm using the word of. So I could say gatherer of. This is the state. This is the integrator with that of. This one is the combiner. And this one here is the finisher. Okay? So I'm doing this technique here, I'm able to parameterize things. So instead of hard coding that 10, I just created a bundle by from this. Okay? And I'm just returning a new gatherer. And notice over here, I don't know if you knew this for IntelliJ. IntelliJ users here? Okay, look at that. Boom. Boom. All right. So right over here, if you notice that, it may be hard to see here. There we go, a little bit closer. The I is in purple. So what we're doing here is that's a closure, right? And that's always highlighted in purple when it comes to IntelliJ. So I think that's pretty cool as well. Okay. There are terms, and so let me do this one. That way I can, provide some sort of extra value in here. There are terms called non-greedy on here, and I think I have a better one a little bit further down. I was trying to clean this one here. So I have a couple of them here. This one is non-greedy, and this one is greedy. Let me run this one, and I'll be able to tell you what the greedy is. Yeah, take a look over here. Greedy is, let's say I'm going to talk to this side over here. I don't care what happens, just give me all your elements, right? Give me, right? And so right over here, I have integrator invoked, and I finally have the answer here, but notice it just keeps on going, okay? So you could stipulate whether things are greedy or not greedy. So this one over here is the non-greedy. Now, what's the difference here, and where do we see that? Well, one of the things you could do is a integrator of greedy. Okay, and that's what makes it greedy. This one is not greedy. That's just going to be a of. I think this is the one that works. I hope it is. Yeah, there we go. Notice the difference here. One was you were getting slammed with all the elements here. But this one over here was non-greedy. And when I say I'm done, then I'm done. Okay. Now, what's the purpose for this? And I think I had some notes on here. It's just how it's implemented. So something that's greedy is this. If you're using non-greedy, behind the scenes, what it's using is try advance. But if you're doing greedy, it's doing a for each remaining on there. So the try advance is like, okay, we'll try to advance a little bit further. But if it's done, then it's done. Whereas for each remaining does what? Right? Just like throws everything out. So depending on what it is that you want to do, for each remaining being greedy is going to be a little bit faster just because it doesn't care. It's just going to turn on the faucet. Yeah, kill it, thank you. All right, excellent. And that's what we have there for a gatherer. Okay. Statements before super. Let me just mention this. JEP 0. Go to it. It's good reading. JEP 0 will show all the JEPs and what's available in here. And you get to see I didn't know that one. Vector API is on number 10. They hold the record there for the incubation. But all the new things that are coming out are on here. And for the most part, it's all excellent documentation. So this one has gone through different names. And I believe this one now, is it called concise method bodies? No, that's not what that one's called. Those are draft JEPs. Let me come in over here. These are delivered features. And here's this one, flexible constructor bodies, I think is what the new one is. Yeah. So this one's now called flexible constructor bodies. This one's on second preview. What's going on here? Well, this one pretty much sums it up. And that's the example that I have. But this one is the following. Positive big integer, you're bringing in a long value for this. And the thing here is that you have a rule in Java, and you've had this rule in Java forever, which is call super first. Okay? Well, what's the problem here? I'm going to call super, and that's going to call the super class, 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 however many chains down that you are. So that's a lot of work that's already been done along the way, right? This is like you making a birthday cake for someone, and you say, voila. And they say, yeah, they don't like that kind of frosting. I'm sorry, right? You're like, what? I put in all the work. All right. Same sort of thing is happening here. They're doing all that work, and they're saying, oh, yeah, you know what? That value, that's totally wrong. Right? Same sort of thing. You put a lot of work into it. So this goes through like different ways that you can go about it. And so they have like a static that's associated with it, and verify it's positive before it goes up the super chain. So that's one way to go about it. But this one is, why don't we just do this? Check the value first, and let's just be flexible with that super and be able to put that super right where it needs to be. And so that's what this one is. This JEP just used to be called that, but here's just the proof that everything works as planned. So I'm getting no errors in here, and it totally works. Now, what's the trade-off here? So let me scroll down on here. They have some particular trade-offs here. The trade-off is that you can't use the word this, or you can't use the this reference within the constructor. And if you think about it, that should make sense. And I don't think that's going to require too much of a cognitive load on your part to understand the reason why. That object doesn't exist, right? What are you going to be referring to? So class A int I. Can I do system out print line this? No, you're in the constructor. It doesn't exist yet. Can I do var x is equal to this dot I? No, I doesn't exist yet. We barely constructed the object. Hash code? No. Var x is equal to I? Again, no. That's implicit though, but there's no I yet. There's no hash code yet. And then, the super on there. So some rules that you would have to abide by, but again, that should not be overwhelmingly scary. If you know the way your object-oriented programming works, then I think you're fine. All right. There are probably some other small fine-grained details, but for the most part, you should be able to get that. Okay, cool. Oh, you know what? I need to promote this. Give me a second here. Let me get this here. How many of you know about MCS, just out of curiosity? Has nothing to do with Java, but I just want to make sure you know about this. I got a big audience here, so why not? Anyone know about MCS? Raise a hand. Okay. Yeah. All right. So this is available. How many of you use SDK Man? Okay. Ooh, that's a low number. Okay. So SDK Man, check out sdkman.io. SDK Man allows me to install and map Java. Again, sdkman.io. I'm going to take a little detour here because I can. Anyway, so you'll notice here I have lots to choose from, and it installs the JDKs for you really nicely. And it allows you to have multiple ones. So like here's all mine right here. I use Tamarin usually, and I use Zulu really. So if I need to switch to these, well, I could do an install Java. Well, let me come back to that list. Since a lot of you didn't raise your hands. If you want to install something, let's say I want to install this Amazon Corretto here. what I'm going to do is I'm going to copy that one there, and I'm going to do SDK install Java, and you put the identifier in, and that will install it. Okay? Now, you can have multiple ones now, like I do, and so I'll have SDK use Java, and here it is. Since I do a lot of trainings and a lot of presentations, this is my go-to. I don't have to change the path all the time. It's not a big deal. I just hit tab, and I get to choose whichever version that I need to jump to. Okay, you can have as many different versions as you like. Not only that, you can do this, right? I can have different Mavens. I could have different Gradles. I don't use Gradle usually, but I think I have a few already here. And MCS. Ooh, what's that? So I just want to tell you about this little utility. Let me ask all of you something. When you look for dependencies, where do you go? Like, I want to know the version for Spring Core. How do you do it? Something like I'm hearing like Search Maven or whatever the website is. How many of you use mavenrepository.org? Okay, some of you do. Check this one out. MCS search Spring Core. I don't use Spring, but I'm one of the few Java programmers that don't do Spring. But anyway, here we go. Boom. Nice, right? You're on your computer. You don't have to go to a website for that. And so that's pretty cool. Let's say here's this one, but I don't want to use 7.0.0.0.om4, but I want to see what else there is. MCS search, blah. Okay, cool. Oh, let's say I like this one. So I want to look a little bit more here. So there it is. And I'm going to do it again. MCS search, blah, 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 with an actual version. And now what that's going to do is going to return that dependency. Nice, right? And you could also do a format on this. I don't know if this will work. Maybe it will. Yeah, it does, right? So it'll provide whatever flavor you want. It's Maven by default, but if you want to do Gradle or if you want to do SBT or whatever build tool that you would like, it'll provide that to you in the format that. Okay, cool. All of you are happy now, I bet. You're like, man, that was a useful tool. All right, excellent. Very cool. Implicit declared classes and enhanced main methods. Uh-oh. What's up with this? All right, let's take a look at this one. I'm not going to go through the slides. Let's just have some fun here. Let me see right over here. I am going to go to... Oh, it's right up here. Implicit main. Oh, this is giving it away. Don't look. Everyone turn away. Public class hello world, public static void, main string args, and hello world. All right, here we go. Something about this that you should know about. I'm going to do public class hello world, static main hello. Let me ask all of you, when you learned Java, was it easy? Anybody thought it was easy? Think about like when it's easy now, right? Because you know everything about it. But back then, there were some hard parts. There's a lot of hard parts. I teach Java, and I got to tell you, teaching advanced Java, as far as a teacher perspective, a lot easier. Advanced is way easier. Because if you get someone that's never seen this before, oh my goodness, what are you trying to explain? So one of the things that's like really hard is like class path. Okay? Have you ever tried to do that? Like someone who doesn't program in Java, what a class path is? Man, you're going to be there all day. That's hard. But one of the other ones was this one. What's static? Oh boy. All right. It's C, the class path you have here, and then you have these classes. They get loaded by the class loader, and in that class you can refer to a method that is, blah, 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 right? You lost them already by that part, right? So why do you want it? What's a class? Okay. What's system out print line? You take a look at other languages, and do you have to go through that much work? That's a lot of work. So here, let me start here with this base here. And I have this run app here ready to go. I don't know what version it was, and I should probably research it. But did you know, like for some like simple classes, you don't have to do a Java C. You can just do Java. This has been out for a while. You just do Java on the class, and boom, there you go. Okay. Now, what I'm going to do here is Java enable preview source 24 and hello world .java. Let's do a little canary test here. Make sure everything is running, and there it is. There's the hello world. So I'm just running this Java enable preview here. All right, here we go. Let's get rid of stuff. I don't like that static. That makes me sad. Okay. And let's come in again right over here, run it, and let's see what happens here. Oh, cool. I still get a hello world. All right. So I was able to get rid of that. Nice. Let's see. Arrays, like for as a beginning programmer or teacher for many folks, you know, I'll get the question, what's string args? I'm not going to tell you that right now. All right, let's take a look at that one, and let's run it. Okay, still working. Look at that. And as long as you have that enabled preview, we're good to go. All right. Public. What's public? I don't want to tell you. Okay, there we go. Looking good. All right, let's give that one a try. Oh, here we go. Oh, look at that. Everything still works. All right, we're continuing on. Let's see, who do I want to get rid of next? Let's get rid of that. I don't care about it. What's a class? I don't know. Leave me alone. All right, here we go. Are we still going? Yeah, nice. All right, let's go a little bit further in. I don't like that system out. What's system out? I don't want to tell you. Plus, it's weird, right? System out. Have you ever dug into it? It's like a weird statically exposed out method inside of system. I don't know if this is true. I think it's true. Maybe an urban legend. I don't know. But supposedly they got rid of system out println in like Java.101. And everyone freaked out and they're like, no, I need that. And then they kept it, and then that's the way we've been ever since. Okay? So does this work? Is this Java? Well, let's go to run that one. It is. Oh my. All right. I think that's as far as we can go. The void does not work. You still need the void because you'll need some sort of return type. So you'll see that there, that has an error associated with it. But yeah, there you go. There's the new hello world. Okay. Pretty nice. Also, there's this new class called IO as well. And I don't know where it's from. Can't be that, can it? Something like that. If I get it wrong, apologies. I'm still trying to get used to it. Yeah, I'm trying to remember. But there is something called an IO class now as well. And you could use that. In fact, let me just come right over here. It's about time I should learn it. Nothing like learning things on stage here. Let's see. This one is module import. If I don't find it right away, then I'll ditch it. Yeah, here it is. Third preview. And let's see if it's in here. Oh my gosh. Somewhere in here. Description. Yeah, it's somewhere in here. What's that? IO dot? .io. Yeah, let's see. If I don't find it, I'll just move on. Oh, there it is. Java.io.io. I thought I got that right, but here it is. Okay. So then, and if you do an import static on that, you could just say println. Right? All that work for nothing, right? Now they're just going to get rid of that. But I love public static void main string args and system out up. Right? We have that etched into our brains. But yeah, times are changing. Okay, cool. Anyways, that's what that one's about. Launch multi-file source code programs. I think this one's a great idea. And here, let me just jump right to the code for this one. What's up with that one? Well, the idea for this is, one, they wanted to do something where you don't have to use a build tool or really simple stuff, right? If you got a lot of dependencies, build tools, you're going to have to use a build tool. And we love our build tools. Maven people, I see you out there. All right, Gradle people. Some of you raise your hands twice. All right, sounds good. Anyway, but yeah, whatever your favorite build tool that you have, that's really great, right? You have your dependencies and manages all that, and you get reports and other things like that. And great for big major projects. Is everything a major project though? And sometimes you just need to do something really quick and easy, and it's just a small little helper application that you want to do. Do you need Maven or Gradle for that? And oftentimes we just do, just because we're used to it. But now we don't necessarily have to, okay? So what we can do is, we can run an application, have some libraries associated with it. Here, let's do the simple one here, which is this one here. And let's see. Yeah, let me go to this one. Sorry about that. I couldn't make up my mind. So let's say I want to do this one here. I have an application. I have some JSON. I want to parse it, and I'm just printing out a result. Boom. Okay. And here's the parser. And I want to use Jackson for it. So my dependencies are rather minimal. I would think if you're going to be doing more than 10 dependencies, you probably need a build tool after that. But if it's something simple like this, I'm just going to download some jar files for here. And that's it. That's all I really need to do. I don't need a build tool or anything else like that. It's in the small. Why would I write small programs? I do it because I do, architecture workshops. And a lot of times, the only thing that I need to do is just create, an application, put it in a Docker image, and then just go. And it's a really simple application, but I'm using it as a proof of concept or something. And I think you do the same as well. You create proof of concept, small applications as well to prove a point. That's where this comes in. And it's related to this JEP right over here, which is Simple Web Server. Anybody hear of Simple Web Server? Okay. This has been announced, and I think announced pretty well. There it is. Came out in JDK 18. And I love this one. So my story behind this one, and if you were in a previous session of mine, I had talked about this one as well. But what this one is there it is, a simple web server. I was looking for something for creating a simple web server, and it didn't even click when I asked that in my own head. I'm like, I really need a simple web server. And I even asked AI, hey, how do I go about this? And they're like, well, bring up your Python and then start to use Flask. And I'm like, I don't want to use Python and I don't want to use Flask. Is there, and I think I actually wrote this out, is there something in Java that I can do a simple web server? I don't even think I hit return because I knew about this. And I'm like, there it is. We have it, right? They have Flask, and a lot of these languages have these simple, web servers out there. But that's what this one is. Now, take this one and complement it with, a small-based application. Delicious, right? Why do I need Maven for this? I just have a simple web server that I can use. That's where this comes in. So for something like this, you just have a class with a main method. Okay. And with that previous one that I showed you, this could likely just look like void main, and you're off and happy, right? Here's just another class where I have a parser, and that's it. That's my simple application that I wish to run. And so what I could do for this, again, no build tool, just Java, class path, wherever that's going to be located, the libraries, and then the prog.java or wherever the main method is going to be. And you're going to be a happy person, right? And there we go. Done. There's my application. So I absolutely love that. Maybe. if I can figure it out. There we go. All right. Let's take a look at this one here, because there are a couple of items in here that you just need to be aware about. This one has a class called AUX. This one has a class also called AUX, and you can't do that. So if you're thinking about doing this and you're going to have multiple classes with the same name, what you're going to end up with here is the following, right? You'll have an error here, and it's going to say right down there, duplicate class AUX, okay? So I'm doing a thumbs up. Yay, errors. But yeah, you're going to end up with an error there. Here's a simple case, but this one's, I guess, not too simple. I should probably rename it something. The only thing to worry about here is I have classes Zoom, I have class Prog, both have main methods, and both are going to be calling the helper down here. So I have helper run with an exclamation mark, helper run with a question mark, and I'm going to be calling that helper. And which one's going to win? Ooh, interesting. Well, let me go ahead and run it. I think you probably already know the answer, but I'm going to go ahead and run this, JDK 24, and there it is. Hello with an exclamation mark was the winner on that one. But why? Why did it do that? Well, because this is the top one, and that's what the answer is here, okay? If this one was down here, so Zoom ends up down here, and Prog is the one up top on this, then instead of exclamation mark, let me go ahead and run that one, and there we go with that one, okay? So pretty awesome. Let's see. So let's come back over here and continue on. So switch expressions have gone through a lot as well, and keeps evolving, but I think it's approaching not the end, but to a place where like we have everything or nearly everything that we want from this. How many of these switch expressions? A lot more now. Expressions meaning you run switch and you have something returned. Let me fill you in on that. So I didn't get too many hands there. So yeah, let's just jump into code and make sure you get all the information on this one. So some of you know about it, some of you do not, but let's go ahead and cover that. So the idea for this is the following. Do I have a switch? Pardon me here. Yeah, enhanced switch. Let's show that one and get everyone level set here. This is the way Java used to be back in, well, it's still like that now, but you don't have to run it like that. Here's the 90s version of Java. And remember, Java was coming from and inherited from C++ and C. So they were like, yeah, we need to be like them. And so this was the switch statement. And so we would have a birth month here, but one of the problems is, take a look at the line 18 up here. In order to do a switch statement, you have to have something that's mutable up here, right? Something that's going to be changed here. So the way this would work is if you were born in August, let's say you were born in August, you would ask about the birth month, and then is it January, March, May, July, August, or October? So let's say it hit August. And so what would happen here is that would just fall all the way down. The result would be 31. And then you have to do this nonsense here of like adding a thing called break, okay? Which would then return the result from it. But that was too much work. So what we ended up having was something like this. Now, this is an expression. Notice the difference here. Notice what it looks like before the word switch. Nothing's there. But if we take a look over here, we are returning a result, and we could even make it final. That's an expression, not a statement. Expression returns something. It evaluates something, and you get a return on it. So given that birth month now, look how nice that is. So that looks great. I love that. And we could even do this. Hey, in case it's January, March, July, August, or December, just return 31. In case it's this one, just return 30. In case it's this one, just return 29. That looks fantastic. And, you know, I can, if I'm doing something like a side effect or something, I can go back to yield. But that's pretty flexible. And that's what a switch expression is. Switch statements, if you're around for a long time, you just abandoned it for a long time, but now switch expressions have come out and you're like, yeah, I want to use that all the time. All right, so that's really cool. Let's see, what else has been happening on the pattern matching front as well. So here's pattern matching. So first, let's start off with the old days here. Here's what we did in the old days. Is O an instance of string? Well, if so, then I'm going to have to cast it. So that string S, string O, that's called a cast. If you're new to this Java world right now, if it's equal to S, then I could say hello to you. Otherwise, something else. And if it's integer, I want to do something else. Well, a little bit later, and so this is part of the migration that Java has undergone for the last few years. They started tightening things up. So this one says, is O an instance of string? If so, I'm going to bind it to that S. And so I could ask some further questions here like hello to you or returning a string. Otherwise, if it's an integer, again, O instance of integer I. Just bind it to that I. I already know it's an integer. Just give it a new reference and I'm good to go. Great. And let's even go further onto this. O instance of string S, so that's the new value here. And, I'm qualifying it over here. S is not empty. Cool. But then we had support for nulls and multiples, and we could have defaults as well. This is more like a switch statement, and the reason is because right over here, I'm not returning anything. I'm just doing a side effect. If you've not heard that term side effect before, side effects are things that you can't validate afterwards, right? So printing to a screen, I can't really validate that. So there it goes. Writing over to a network, writing onto a hard drive, and updating a state are all side effects. So I'm not really returning anything here. But this is just showing some of the things that the switch statement can do. Then on this one is the switch statement a little bit further in here, and I could do this. In case it's an integer I, then do something with it. In case it's a long, then do something with it. In case it's a double, do something with it. In case it's a string, do something with it. And we're getting pretty happy because now all of a sudden the term switch just became a whole lot more useful for that. Then what started happening is that they started including records as part of this matching. How many like records? You're doing a lot more records now. Records are great, right? And so let's say I have this. Here's the structure of the team. By the way, IntelliJ users, Command Y, beautiful. And there it is. Command Y is showing what the code is without ever going to that code. Is that great? So there it is. That's record team, string city, string name, wins, and losses. So what I could do with this is amazing. Look at that. I can. I'm bringing an object, and I'm asking here if it's a city. I want to do what's called destructuring, which is, hey, I want to take out the city. I want to take out the name. I want to take out the wins and the losses, and I want to do something with that. Wonderful. That's called record matching. Now, this is new. What is this? This is an unnamed variable. If I don't want to create a variable, I don't have to anymore. I just put an underscore in front of that. So in this pattern match, I want to do team with city, name, int underscore, which is my wins, and the other underscore is losses. I'm just showing you different ways that you go about it. I don't care about the wins or losses because I'm not going to do anything with it. So let's just blank those out with an underscore because I'm just going to be using the name and the city on there. Wow, that's getting really, fascinating here. But check this one out. I want to match with a record, but I only want to match with a record where the city starts with M. What? So match the team, get me the city, get me the name. I don't care about the wins or losses, but I want to qualify it, called a guard. I want to qualify it even more because I only want the cities that start with M. Nice, right? And I get to qualify it. Otherwise, just give me the general team, and I'm just going to say a team right over here. Now we're getting really advanced here, okay? Here's another one. Pattern match teams that have a winning record. Get me a team when the wins, which is coming in from over here, are greater than the losses. team from such and such has a winning record. Otherwise, they have a losing record. You see how concise and beautiful that is? That's great. And then finally, right over here, this is going to be new here. In fact, I don't think it's released yet. Let me just verify here. Time keeps on slipping too quickly. Primitive types and patterns, second preview as of 24. So not official yet. But this is now going to become a part of your pattern matching it's now out in 24, but as a preview. So not the official one. Okay. But isn't that awesome as well? Okay. So Java has, been coming a long, long way for all of these. Okay. I showed you the unnamed variables. The unnamed variables, you just do an underscore. If you're not going to use it, you don't have to use it. And that's really one of the great parts here. And in fact, let me, I think I have the example here. A couple of examples here. Like in this one over here, I'm just calculating a total. I have no use for that order. So I could just do that. This acquired context, I'm not using that. We'll just blank that part out. How about this one over here? String S, integer parse, number format exception, right? You have that exception there, and maybe you're not actually using that for whatever reason. Blank that out, okay? This one right over here, right? That V is not actually being used anywhere as part of a lambda. Blank that part out, right? So it's very, very much multi-use for those unnamed variables, okay? And I will end it right there. So I hope you got a lot out of that. MCS. All right. Thanks, everyone. Appreciate it.